Hello, my name is Zach, and I'm going to introduce you to the fascinating subject of computers. We use them every day. Our phones, laptops, hold on, let me check my other pocket, and gaming consoles are all computers. But my point of reference for today will be the common desktop computer. Despite my focus on desktop computers, most of this information should still apply to many of your other devices. First, the CPU, or Central Processing Unit, is the brain of the computer. This processor makes constant calculations and decisions. The speed of a computer mostly relies on the speed of this single expensive little chip. The majority of family or office computers contain a processor that costs $200 to $500. The CPU works by performing tasks the operating system, such as Windows or Mac OS, for you Apple users, tells it to complete. The CPU connects to the computer's motherboard with hundreds of pins. It is located behind this fan. Well, how is the speed of a CPU measured? Well, the CPU speed is measured in the number of clock cycles it can execute in 1 second. Modern CPUs often reach a frequency of between 3 and 5 gigahertz, which may not seem like much, but that actually means 3 billion to 5 billion clock cycles per second. Now, clock speed isn't the only determining factor in the capability of a CPU. Modern CPUs also have multiple cores. This allows CPUs to process different applications on different cores instead of waiting until one processes and then processing the other. This also allows software, such as video editing software, to split up its workload to multiple cores. This is called parallelization. The majority of CPUs have 2 to 8 cores, and the number of cores a user needs is determined by what they use their computer for. An office computer, or computer used for school, will not benefit from over 4 cores, while someone who uses multiple applications at once or plays modern video games will benefit from 8 or even more cores. A user who works with software that implements parallelization, such as video editors and engineers, will benefit from 8, 12, 16, or even more cores if they are doing professional work. The most common CPU manufacturers are Intel and AMD, or Advanced Micro Devices. The graphics card is a card that cools and contains the GPU, which is the Graphics Processing Unit. This GPU renders the pixels and images displayed on the monitor. This card is especially useful for 3D rendering, and a dedicated graphics card, like the one located right here, is nearly essential for 3D software, such as engineering software and new video games. A GPU's performance capabilities are measured by their amount of CUDA cores and their clock speed, like a CPU clock speed. Modern GPUs often have a boost clock of between 600 MHz and 1800 MHz, which is a lot slower than CPUs. The best way for people to pick a graphics card is to look at benchmark results in the different applications they plan on using it for. This will show how well it runs each application. Many gaming enthusiasts looking to buy a graphics card will look at how many pixels the card can push and refresh per second. This is to make sure the game is not choppy and pixelated. A graphics card contains a dedicated GPU, but there are also often integrated GPUs attached to CPUs. These are much less powerful GPUs meant for people who are simply using their computers for web browsing, such as simple 2D applications. Integrated GPUs can also often run simple 3D applications that don't contain much detail, such as the popular game Minecraft. Many casual users stick with these integrated GPUs, as consumer-grade graphics cards range from $100 all the way up to $1,800. While professional targeted graphics cards for movie effects and simulation for big corporations can cost over $5,000. The main GPU manufacturers are NVIDIA and AMD, although the actual graphics cards are built by countless companies such as MSI or Microstar International and ASUS. Yep, that's right. AMD makes both CPUs and GPUs. Now, the motherboard which is behind all these components connects all the computer components. The motherboard has a socket for the CPU, a slot for the graphics cards, slots for the RAM, and connectors for the storage drives. The motherboard also has connectors for the power supply. Different motherboards are compatible with different CPUs, such as motherboards with the LGA 1151 CPU socket being needed to connect newer Intel CPUs. The most common motherboard manufacturers include companies such as MSI and ASUS. The next topic is the storage devices that connect to the motherboard we just talked about. This storage device right here connects to the motherboard with this wire. The two main devices used to store a computer's data are hard drives and solid-state drives, or SSDs. SSDs are becoming more popular than hard drives for the average consumer due to their superior speeds and smaller size, although hard drives are still used for their much cheaper mass storage. SSDs are often 3 to 20 times faster than hard drives. Hard drives store data on a physical spinning disk and read their data with a header that moves around the disk, while SSDs have no moving parts and store their data in flash memory. The quality of a drive is measured by its storage capacity in gigabytes or terabytes, along with its read and write speeds measured in megabytes per second. The read speed is the speed at which it loads data already on the drive, while the write speed is the speed at which it can download new data. This next component is much faster than even the fastest SSDs, but it is much more expensive and requires electricity, or it will lose all of the data temporarily stored on it. RAM, or Random Access Memory, stores data that will soon be needed by the CPU, and it is located right beside the CPU. RAM lets the user multitask by letting them quickly access data that has already been read off of the drive, so that they do not have to wait for it to load again. This data can include applications such as a search engine or mail application. RAM capacity is measured in gigabytes and its speed is measured in megahertz, with modern RAM settling in at around 2,000 up to 4,000 megahertz. The most common RAM capacities are 8 and 16 gigabytes, with there often being 2 sticks of RAM in a computer that add to this amount. The more RAM a user has, the more data can be temporarily stored on the RAM, taking loads off the CPU and storage drives. 8 gigabytes of RAM costs around $50, while 16 gigabytes of RAM costs around $100. Computers used for school and office work should have 8 to 16 gigabytes of RAM, while professional workloads such as simulation and video editing softwares can use 32 gigabytes of RAM all the way up to 256 gigabytes of RAM. The most RAM Windows allows a computer to have is 2 terabytes. This is insanely unnecessary for most people. The most common RAM manufacturers are Corsair and G.Skill. Perhaps the least interesting, but one of the most important components of a computer is the power supply, which is located right here in this computer. The power supply controls how much power goes into the computer. This component keeps a steady supply of power supply, by intaking power from the wall outlet and outputting it to the computer. It also helps protect the computer against power surges, which can completely fry a computer. The specifications of a power supply are determined by their wattage output and their power efficiency rating, which ranges from 80% efficiency, meaning 80 plus efficiency rating, to 94% efficiency, meaning 80 plus titanium efficiency rating. Most modern computers require a power supply with 300 watts to 700 watts. These power supply prices range from $50 to $120, and this price depends on their wattage output and power efficiency rating. Very cheap power supplies are not recommended, as these can use a lot of power and actually damage computer components. Now that you have a stronger understanding of computers, you may want to apply this knowledge when buying your next laptop or desktop. You could even build your own computer if you feel up to it. The field of computer science is incredibly interesting, and there is an abundance of information and constant advancements. I hope I passed on some of my knowledge and enthusiasm to you. Here is my Works Cited page. Linus Sebastian from TechQuickie was very helpful in explaining computer components in a highly comprehensible way.